All right. So we have this question here that we have to look at. The first one says the figure shows a sketch of a part of the curve C with equation y is equals to 32 over x squared plus 3x minus y. Okay, and this prior question, there's x is greater than 0. Okay, that means the values of x as it ranges is all positive. Okay, from 0 onward. The point P, as you can see over here, is that's the point P. Okay, the point P, there's the point P. As you can see, the point P is 4, 6, lies on the curve, and this is the curve. Okay, and the line is a normal to C at a point P. The line L, which is this, is normal at C. Okay, at C at a point P. Okay. The region R, as you can see over here, shaded area, shown shaded in figure 4, is bounded by the line L, the curve C, the line with the equation x is equal to 2. That is here, as you can see. And the x-axis, as usual. Okay. Show the area of R, show that area of R is 46. Solution based entirely on graphical or numerical method. Okay, let's see. So, if that is the case, let's have a look at it. So, our equation, so it means if you look at the whole graph, you see, we have a point x equals to 2. X equals to 2, and what x equals to 2, okay, and point P is 4, 6. So you see that the x-axis over here is 4. Okay, so that will be the boundary, the limit. Boundary of the limit. So if that is the case, then we can say that the integral with the boundary x equals to 2 and x equals to 4, yeah, bounds the curve. So it's a y integral dx. So this will be the integration. So from 4 to 2, the integral of y dx, and then we know y has been given as the whole equation, which is negative 32 x, then we have plus 3 x squared over 2, then we have minus 8x. Okay, so this the x. So that will be the boundary. As you can see, that will be the boundary if you look at the integration that we've been given. Okay, so y, because we know the y value, and the y the x. So that will be the integration. That's only, so this one will be that. You see, knowing the y given to it. So this is what we have to work it out. So we have to put in the limits of 4 and 2 into the integration to be able to solve it out. So here we are going to substitute 4 and 2. So if we do a limit of 4, okay, so the limit of 4 gives us negative 16, okay, and the limit of 2 gives us negative 26. So when we subtract, then it's going to be minus 16, okay, minus 26, okay. Now we'll do that. We are going to get minus 16 plus 26, which is equal to 10. So this is what we get. Okay. Now let's look at the differential of that. So divide the x of what we have. So divide the x. Will give us negative 2 out 32 x raised to the power negative 3 plus 3 because the 8 will go to 8 to be 0 so that's what we get. Yeah, so that's how it is, minus 1 and that cube plus 3. So this 1x is equals to 4. When x is equals to 4, we have to look for the value for 1x equals to 4 and 1x equals to 2. Okay, so when x is equals to 4, this equals to negative 2 times 32 all over x to the power 3 and plus 3. So when x is equals to 4, we are going to get negative 64 over 4 cube plus 3. So 4 times 4 is 16. Okay, so when we do that, for sure, you know that when we put 4 over here, we are going to divide the x. To be equal to what? 2. So this implies that the gradient, our gradient L is equals to minus half. Okay, so therefore our equation becomes y is equals to negative half x plus c. This is equal. Okay, and with that, if we substitute the values, so this if we put x to be equals to 4 and y to be equals to 6 into this equation, we are going to get 6 into bracket minus half 4 plus c, and this 6 is equals to negative 2 plus c. meaning our C is equals to what? 8. If C is equals to 8, then Y, that means equation L is giving us Y minus half X plus 8. There's a line L. Okay, so when Y is equals to 0, when Y is equals to 0, I hope you guys are following. When Y is equals to 0, when Y is equals to 0, okay, then we are going to have 0 to be equals to minus half of X plus 8. This implies that X is equals to positive 16. Okay, then our limit, the integral for that limit of 4 and 16, okay, with that differential, this is minus half X plus 8, yeah, into bracket dx. And that will be our core mandate to be able to integrate that. And when we integrate this, we are going to get minus half x, 2 divided by 2 plus 8x. So with our limit in mind, which is 16 and 4. Okay, when we work it out properly, when we put the limit in, it's going to be minus half into bracket 16 squared all over 2 plus 8 into bracket 16, and we subtract all this from minus half into bracket 4 squared over 2 plus 8, 4. If you put this one in the calculator and work it out, we get 64 over here, and this one will be 28. So when we subtract 64 minus 28, what do we get? 64 minus 28, we get 36. 36. Yeah, how do you clear it? Minus 36. So this, it will be positive 36. Okay, so this, you see that the area that we've got over here, okay, so the first area that we have 10. So the total area is equals to 10 plus 36. And this will be 46. That is the area bounded by the curve. So that is where we bring our tutorial to the end. I would advise you guys to take your time and go through it for the solution. And that is what we have for this. The area bounded. Okay, show that area bounded by R is 46, and this is what I have proved. Thank you very much for your time. See you again. Bye.